The COVID-19 Early Detection System is a public health tool that aids epidemiologists and researchers in measuring COVID-19 infection rates across populations. Currently, many infection rate models use data from individual COVID-19 tests to determine general population infection rates. While these individual tests are extremely accurate, it is not easy to collect this data into a model reflective of the actual infection rates of a population. Few people actually get tested, and if they do get tested, they don't represent a statistically random sample. The COVID-19 Early Detection System is a low-cost forehead temperature measurement device that can be deployed en masse in high-traffic public places. The naive solution to this project would be to use a thermal camera to identify all the foreheads in a frame and then catalog that data. However, these thermal cameras are expensive. Instead, the COVID-19 Early Detection System uses a low-cost single-element infrared thermometer and waits for a forehead to move into the field of view. When deployed on a massive scale in high-traffic areas, it provides enough data to make good statistical inferences about infection rates. The system uses an extremely low-cost consumer-grade image sensor and a sophisticated face detection algorithm to determine when a forehead is in the IR temperature sensor's field of view. The system runs embedded Linux, which provides out-of-the-box support for OpenCV image processing, 802.11 networking, and multimedia streaming. The system is built around the NXP IMX6, which hosts a single-core ARM Cortex-A7 and features all the necessary peripherals required for the project. The Allwinner A33 was also considered, though it was more powerful than necessary. After proving out the image sensor and IR temperature sensor on an IMX6 breakout board, a first revision PCB was designed. This first spin of boards was meant to better interface with the sensors and parts. The first revision hardware included a 5-inch TFT, but this added unnecessary cost and complexity to the design, while not offering additional features or capabilities. The second revision of the board added a Wi-Fi and Bluetooth module, and changed the layout to better fit into a 3D printed enclosure. For the color camera, the product uses the Omnivision OV7670 image sensor. While this is an older 640 by 480 resolution design, this provides sufficient resolution for facial tracking, and these image sensors are dirt cheap, as low as 30 cents each, which helps drive down the cost of the product, important for massive scale installations. This was prototyped with an off-the-shelf camera module to test the Linux kernel driver support before the actual image sensor was integrated into the PCB design. The product uses the Melexis MLX90614 DCI medical-grade IR temperature sensor, equipped with a 5-degree field-of-view lens to get more precise readings at long ranges. Once the system identifies a person's forehead in the field of view of the IR thermometer, a reading is collected and sent to a web server using a standard HTTP REST API. This web server software was written in ASP.NET Core with Entity Framework and Razor Web Views. The goal of the industrial design of the product was to have a fun, inviting appearance. Several 3D prints helped explore the ideas of its form and function. Painted in bright purple, the product has a circular, bubbly image that looks friendly and inviting. On the back, a standard 1/4-20 threaded insert enables mounting using off-the-shelf camera hardware.